So in this video we're going to be you're going to be learning how to prove trig identities, and really the key to proving trig identities is to change everything into sines and cosines, and that usually gets you started on the path to success. And so we're going to start with example 1, and it's prove that cotangent x over cosecant x is equal to cosine x. And so we're going to start by changing the cotangent and the cosecants to sines and cosines. And so we know that cotangent is 1 over tangent, and we know that tangent is sine over cosine. So cotangent is just going to be cosine over sine because you're doing the reciprocal of the tangent one. And then we know that cosecant is 1 over sine. And so now we're going to keep change flip, and so we're going to change our sign to multiply, and we're going to do the reciprocal of 1 over sine x. And so we're going to get cosine x over sine x times sine x over 1. And your sine x on the numerator and the denominator are going to cancel out, and you're just left with cosine x, which is what we were solving for. So that one is proved. Now for example 2, we're going to prove that cotangent x plus tangent x is equal to secant x times cosecant x. And so like always, we're going to start by changing the cotangent and the tangent to sines and cosines. And so we get cosine x over sine x plus sine x over cosine x. And our next step is going to be to get a common denominator. And so to do that, we need to have our denominator equal to cosine x times sine x. And so on the left side, we're going to multiply the top and the bottom by cosine x. And on the right side, we're going to multiply the top and the bottom by sine x over sine x. And so that will get both of these to be cosine x times sine x, so we can combine the top and the bottom. And when you do cosine x times cosine x, you get cosine squared x, and sine x times sine x is sine squared x. And so this will become cosine squared x plus sine squared x over cosine x sine x. And this is a trig identity. Cosine squared x plus sine squared x is equal to 1. And then we just move the denominator over, so we get 1 over cosine x sine x. And now we're going to split this up into 1 over cosine x times 1 over sine x, and these are both also trig identities. We know that 1 over cosine x is secant x, and 1 over sine x is cosecant x, and so we have secant x times cosecant x, which is what we were trying to prove, and so that one is done too. So our last example is going to be prove that tangent squared x over tangent squared x plus 1 is equal to sine squared x. And so just like before, we're going to change our tangent squared x into sines and cosines, and so if you have a square here, then your sines and cosines also have to be squared. So tangent squared x is going to become sine squared x over cosine squared x, and same thing on the bottom. And so now, if we look at the denominator, we're like, this isn't an identity, but we do know some other identities that we could possibly change this to. And so one that comes to mind is sine squared x plus cosine squared x is equal to 1. And so if we want to achieve that, we have to change this 1 into cosine squared x over cosine squared x so that these denominators will match, and we can add these two numerators together. And cosine squared x over cosine squared x is equal to 1, so we can change the 1 to that. And so here I've just written it out when we combine the denominators. And so we have sine squared x over cosine squared x over sine squared x plus cosine squared x over cosine squared x. And so like before, we know that this is equal to 1, and so I rewrote it here with this as 1. And so now we're going to keep change flip again, and so we're going to have sine squared x over cosine squared x times the reciprocal of this, which is cosine squared x over 1. The cosine squared x's cancel out, and you're just left with sine squared x, which is what we were trying to prove.